Hello, student. Welcome back to this topic of arithmetic progression. And as you know, in the part number 9, I have been solving this exercise 1.3 of this chapter, arithmetic progression. So these are the problems present in this exercise. So I have solved the problems up to 10. And now I have to solve the problems from 11 onwards. Okay. So the 11th problem is like this. If the sum of the first n terms of an AP is 4n minus n square, what is the first term? That is S1. What is the sum of the first two terms? What is the second term? Similarly, find the third and the 10th and the nth terms. So this is the problem. We will see its solution. So the problem is like this. The solution of this problem is like this. The given that the sum of the n terms is given by this equation, Sn is equal to 4n minus n square. So from this, first we will determine the first term of this sum. So here just what I will do, I will put n is equal to 1 in this equation. What it becomes? It becomes, you see, 4 into n. Wherever n is there, I am putting 1. So 4 into 1 minus 1 square. So 4 into 1 is 4 minus 1 square is 1. So 4 minus 1 is 3. So this is the first term of the above sum. Similarly, find out the second term of the sum. S2, put n is equal to 2. This is equal to 4 into 2 minus 2 square. 4 into 2 is 8. 8 minus 2 square is 4. So 8 minus 4 is a 4. So this is the second term. Then the sum of the first two terms of this sum is S. That is equal to S1 plus S2 you make. As you know, S1 is 3 and S2 is 4. So 3 plus 4 is equal to 7. So this is the sum of the first two terms. Next, we will determine the second term of AP. The second term of AP is given by, it is A2. Remember this formula, it is very important. The second term of the given AP is obtained by the two terms of the sum. So it is S2 minus S1. So S2 is 4, S1 is 3, 4 minus 3 is 1. So 1 is the second term of the AP. Similarly, determine S3 means the third term of the sum. Put n is equal to 3. So it is 4 into 3 minus 3 square. 4 into 3 is 12. 12 minus 3 square is 9. So 12 minus 9 is 3. So therefore, the third term of AP is A3. A3, how you are getting A3? A3, you have to make S3 minus S2. S3 is 3 and S2 is 4. So 3 minus 4 is a minus 1. So in this way, you got the third term of the AP. Similarly, determine S9 by putting n is equal to 9. So this is 4 into 9 minus 9 square. 4 into 9 is 36. Minus 9 square is 81. So 36 minus 81 is a minus 45. So similarly, determine S10. S10, put n is equal to 10. So 4 into 10 minus of 10 square. So it is 40 minus 10 square is 100. So 40 minus 100 is a minus 60. So after getting S9 and S10 terms, I am determining the 10th term of the AP. The 10th term of the AP is written as a A10 and that is given as S10 minus S9. S10 is minus 60 plus S9 is minus 45. Minus of minus becomes plus, so it is plus 45. So it is minus 60 plus 45 is a minus 15. So in this way, we got the different terms. Then to determine the nth term of this problem, what I will give, so I will change the Sn. This is the given sum. Sn is equal to 4n minus n square. Wherever n is there, I will put n minus 1 to get the term beyond this. So here you replace this n with n minus 1. So it becomes n minus 1 is equal to 4 into n minus 1 minus of n minus 1 into square. So multiply this 4 to this bracket. So it is 4n minus 4 and minus. And you have to expand this using a minus b whole square. A minus b whole square is a square plus b square minus 2n, 2ab. So use that formula. So it becomes n square plus 1 square is 1. Minus 2ab means minus 2 into n into 1. Okay. Next. So this is 4n minus 4. And multiply this minus sign to this bracket. It becomes minus n square. And this minus 1. And minus of minus is plus 2n. So this is equal to 6n. How? 4n is here. 4n is here. Just a minute. I will use the mouse. So, okay. Not required. So 4n is here. This is 2n. Here, so it gives 6n. And minus n square you write as it is. And this minus 4 and minus 1 gives a minus 5. So this is the value of Sn minus 1. And this is the value of Sn is equal to 4n minus n square. So nth term is obtained by subtracting these two. That is by making Sn minus 1. So this is going to put the first put the values of Sn, that is 4n minus n square, and minus put the values of Sn minus 1, that is 6n minus n square minus 5 is the value of Sn minus 1. So here you write 4n as it is minus n square and multiply this minus sign to this bracket. It gives minus 6n and minus into minus gives the plus n square and minus into minus gives the plus 5. So n square get cancelled. So here 4n is there and minus 6n is there. That gives minus 2n plus 5. So I will write this as 5 minus 2n. So this is the value of the nth term of this equation and this problem. So that is equal to Sn minus 1. So this is the nth term. So the problem is solved. Next, we will move to the problem number 12. The problem number 12 is like this. You see, find the sum of the first 40 positive integers divisible by 6. This is the problem number 12. And let us see how is its solution. Problem number 12. This is 10, 11, 12. It's a small problem. The terms divisible by 6 are like this. First few terms, they are 6, 12, 18, 24. Because you can see these are all numbers divisible by 6. Or these are also called as the multiples of 6. So this is the AP. And these are the few terms. And in this AP, first term A is 6 and the common difference is 6 because 12 minus 6 gives the 6. And we have to determine the sum of the 40 terms, first 40 terms. For that, just use the sum formula. So S40 is equal to n by 2. So 40 by 2 into the bracket 2a. 2a means a is 6. So 2 into 6 plus n minus 1. 40 minus 1 into d. D is 6. Simplify. It is 40 by 2 and 2 into 6 is 12 plus 40 minus 1 is 39 into 6. So this gives 40 by 2 is 20 into the bracket 12 plus 39 into 6. 39 into 6 is 234. So this is equal to 20 into 246. So 20 into 246 is 4,920. So this is the solution of problem number 12. Now I will move to the problem number 13. Let me see what is the problem number 13. So the problem number 13 is like this. Find the sum of the first 15 multiples of 8. So that is the problem. Problem 13 is like this. So this is 11, 12, 13. It's also a small problem. Find the sum of first 15 multiples of 8. That means we have to list out the numbers which are divisible by 8, or they are also the multiples of 8. So the few terms which are multiples of 8 are like this: 8, 16 means 8 multiplication table it is. 8 ones are 8, 8 is a 16, 8 3 is a 24, 8 4s are 32, 8 5 is 40. Like that, you will get so many numbers. So we have to count the 15 terms, this kind of terms. And in this AP, first term is A is equal to 8, and common difference is 16 minus 8 or 24 minus 16, that is equal to 8. And we need the sum of 15 terms. So n is equal to 15. So use the sum formula. Yes, 15 is equal to 15 by 2 into 2 into A. 2 into 8 plus n minus 1 is 15 minus 1 into D, 8. So this is equal to 15 by 2 into 2 into 8 is 16 plus 15 minus 1 is 14 into 8. So this is 15 by 2. So into the bracket 16 plus 14 is 112. So this is equal to 15 by 2 into 16 plus 112 is 128. Here you make some cancellation. So it is 2 ones are 2 6 are 2 4s are. So 15 into 64 gives a 960. So this is the sum of the first 15 terms which are divisible by 8 or which are multiples of 8. Next, I will go to the problem number 14. 13 is also solved. So 14 problem is like this. Find the sum of odd numbers between 0 and 50. So that is the problem. We have to count the sum of the odd numbers between 0 and 50. So it is like this. It is the 14th problem. The sum of the odd numbers between 0 and 50. The odd numbers between 0 and 50 are like this. You have to start from 1. Means all odd numbers 1, 3, 5, 7, 9, 11, like that. We have to go up to 49. 49 is the last number. So here A, first term A is equal to 1 and common difference D is equal to 2. And nth term, you have to take this as the nth term, En is equal to 49. Using the relation, first you determine how many terms are there in this given AP. For that, you take this nth term formula. An is equal to A plus n minus 1 into D. So An is 49 is equal to A is 1 plus n minus 1 into D. D is 2. So you take this one, this side it becomes 49 minus 1 is equal to n minus 1 into 2. 49 minus 1 is 48 is equal to n minus 1 into 2. Or you multiply this to this bracket, 48 is equal to 2n minus 2. And take this minus 2 to this side, it becomes 50. So 50 is equal to 2n, or n is equal to 50 by 2. That means 25. So there are 25 terms are there in this given AP. Then we will find out their sum. So S25 is equal to n by 2, 25 by 2 into 2a. A is 1 plus n minus 1, 25 minus 1 into D. D is 2. So 25 by 2 rate as it is, 2 into 1 is 2 plus 25 minus 1 is 24 into 2. So this is equal to 25 by 2 into, you sum the, it is 24 into 2 is 48, 48 plus 2 is 50. In this way, so you cancel here, 2 ones are 2 25s. So 25 into 25 is 625. So The sum of the first 25 terms of the odd numbers between 0 and 50 is 625. So the problem is solved. Next, we'll go to the 15th problem. The 15th problem is like this. So this is the 15th problem. A contract on construction job specifies a penalty for delay of completion beyond a certain date is as follows. Rule 200 for the first day, rule 250 for the second day, and rule 300 for the third day, etc. The penalty for each succeeding day is being 50 more than for the preceding day. How much money the contractor has to pay as a penalty if he has delayed the work by 30 days. So that is the problem. So this is the 15th problem in this exercise. So its solution is like this. So the numbers generated here is in the form of penalty or like this because the fine starts from 200. Then fine is increased 50 rupees per day. So the terms generated here are 200, 250, 300, 350, dash, 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 dash. Okay. So here, therefore, the first term becomes the 200 and common difference is the 50 and n is equal to 30 because 30-day delay is there. Then their sum is S30. S30 is equal to n by 2 means 30 by 2 into 2a. A is 200 plus n minus 1, n is 30 into 50. So this is equal to 30 by 2 is 15 into 200 into 2 is 400 plus 30 minus 1 is 29 into 50. So this is equal to 15 into 400 plus 29 into 50 is 1450. So this 1450 plus 400 is 1850. So that is multiplied by 15. So this gives 27,750. So the penalty for 30 days the contractor has to give is 27,750. So in this way, the problem number 15 is also solved. I'll go to the problem number 16. Problem number 16 is like this. A sum of 700 used to be give 7 cash prizes to students of a school for their overall academic performance. If each prize is 20 less than its preceding prize, find the value of each of the prizes. So the 16th problem is like this. And its solution is like this. Okay. The total sum of the rupees or the cash prize is 700. Here is 7 prizes are to be given. So therefore n is equal to 7. Let us say the first prize is X. Then he tells that the prices, the succeeding prices are 20 rupees less. So the next price will be X minus 20. Next price will be X minus 40, X minus 60 like that. So we are getting the terms of the AP. So in this AP, the first term is X. The common difference is minus 20. You can see here, common difference I have determined. X minus 20 minus X. This is the second term. This is the first term. So X get cancelled. So it is minus 20 and n is equal to 7. Using the sum formula, we will determine the value of X. So 700 is equal to n by 2. 7 by 2 into 2 e into a. A is X plus 7 minus 1 into d minus 20. So here I have cancelled 7 ones are 7 twos are 14. So it get cancelled and this in this bracket it is 2x plus 7 minus 1 is 6 into minus 20. So here 200 is left is equal to this 2x comes and 6 into 20 is minus 120 or arrange the term, write 2x first. So 2x is equal to, take this to LHS side, it becomes 200 plus 120 So it is 320. That means 2x is equal to 320 or x is equal to 320 divided by 2. So that is equal to 160. Therefore, the value of x is 160. Therefore, the values of prices are to be divided like this. The first price will be 160. Next will be 140, 120, dash, dash, dash. It goes up to 40 and which total equals 700. So in this way, the 16th problem is solved. Now I will move to the 17th problem. The 17th problem is like this. In a school, students thought of planting trees in and around the school to reduce air pollution. It was decided that the number of trees that each section of each class will plant will be the same as the class in which they are studying. Example, a section of class 1 will plant 1 tree, a section of class 2 will plant 2 trees, and so on till the class 12th. There are 3 sections of each class. How many trees will be planted by the students? So this is the problem, and we'll see what is its solution. So it's the 17th problem. The 17th problem solution is like this. Here each class has 3 sections, so the terms are 3 into 1 because class 1 students will plant 1. So, but 3 sections are there, so it is 3 into 1. Second class will plant 2 trees, but 3 sections are there, so it is 3 into 2. So in this way, you have to write for all the class up to 12th class. So the terms generated here are 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9, dash, 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 3 into 12 is 36. So this is the AP is generated here, and the first term is 3, common difference is also 3, and the nth term is 36. We have to determine how many terms are there and their sum. So using the nth formula, an is equal to a plus n minus 1 into d, I will put all the values. N is 36, a is 3 plus n minus 1 into d, d is 3. So I will determine the n here. So 36 is equal to 3 plus 3n minus 3. Multiply this 3 to this bracket. So it is 3n minus 3. 3 get cancelled. So therefore 3n is equal to 36 or n is equal to 36 divided by 3 is equal to 12. So that means there are 12 terms in the AP. Then their sum is obtained like this. So it is S is equal to n by 20, A plus AL formula you have to use. So n is 12, so it is 12 by 2 plus A is more first term, that is 3 plus last term, AL is last term, that is 36. So this gives 12 by 2 is 6 into the bracket, 36 plus 3 is 39. Then 39 into 6 is a 234. So the sum of the 12 terms in this AP is 234. So the problem is solved. That means total of 234 trees are required for the plantation by the students from first standard to 12th standard. Next, we'll go to the problem number 18. The problem number 18 is like this. A spiral is made of successive semicircles with the centers alternatively at A and B, starting with the center at A of radius 0.5 centimeter, 1 centimeter, 1.5 centimeter, 2 centimeter, as shown in the figure. So what is the total length of such a spiral made up of 13 consequent semicircles, and you have to take a pi value as a 22 by 7. So semicircles are there here. So for this first semicircle, this much is the length L1. For that center is the A. For the semicircle 2, the length is L2 and center is B. For semicircle 3, L3 is a length and A is its center. So alternatively, the place of this center is changing as the semicircles are changing. So we have to determine what is the total length of the semicircles. We'll go to its solution. Problem number 18. So it is like this. Okay. The radii of the semicircles are given as 0.5 centimeter, 1 centimeter, 1.5 centimeter, 2 centimeter. First, you take the first semicircle. For that, let us say its length is L1. The formula is 1 by 2 into 2 pi R1. Because 2 pi R1 gives the circumference of the whole circle. But these are the semicircles. So you have to divide this by 2 pi R by 2 to get the length of the semicircle. So it is why 1 by 2 into 2 pi R1 is the formula. So 2 get cancelled. So left is pi R1. The value of pi is 22 by 7 into R1. R1 is 0.5 centimeter, but you can write this 0.5 as a 1 by 2 because 1 by 2 is a 0.5. So it is 22 by 7 into 1 by 2. Here 2 ones are 2 11s are 22 get cancelled. So 11 into 1 is 11 divided by 7 is the first term. Second term, similarly, for the second semicircle, directly the formula is pi R2 to get its length. Pi is 22 by 7 into R2 is the radius, that is 1 centimeter. So it is 22 into 1 is 7. Go to the semicircle 3, pi R3 is the formula. 22 by 7 is the value of pi into R3 is 1.5 centimeter. So 22 by 7 into this 1.5 you can write as a 3 by 2 because 3 by 2 is 1.5. So here can make the cancel. 2 2 ones are 2 11s are, and 11 into 3 is 33 divided by 7 is the 33 by 7 is the length of the third semicircle. So the terms generated here are 11 by 7, 22 by 7, 33 by 7, dash, dash, dash. And therefore, the first term is 11 by 7. And the common difference is 22 by 7 minus 11 by 7. So this gives 11 by 7. And the total length of the semicircles of 13 semicircles is obtained by the sum formula. So S is equal to 13 by 2 into 2a. 2a is 11 by 7 into plus n minus 1, 13 minus 1 into d. d is 11 by 7. So this is equal to 13 by 2. And this is 11 into 2 is 22 by 7 plus 12 into 11 by 7. So this is equal to 13 by 2 into 22 by 7 plus 12 into 11. So that is 132 divided by 7. This is equal to 13 by 2 into this LCM is 7 and sum these two, it becomes 154 by 7 and make some cancellation here. So 7 ones are 7 22s are 154 goes. Then 2 ones are 2 11s are 22 goes. So therefore 13 into 11 is equal to 143 is the total length of the semicircles. So therefore L is the total length of the semicircles or 11 semicircles which are generated in this way. We'll move to the problem number 19. Let us see how it is. So in the 19th problem, 200 logs. Logs means they are some pieces of wooden tree. So 200 logs are stacked in the following manner. You can see in the picture, they are stacked one over the another. And 20 logs are in the bottom row. So this is the bottom row. There are 20 logs. 19 in the next row. That means in the second row, 19 logs are there. And next 18 logs in this third row and so on. In how many rows are the 200 logs placed? And how many logs are there in the top row? So that is the problem. We'll go to its solution. So the problem number 19 is like this. It is a simple problem. See, the logs in the first, second, and third rows are like this: 20, 19, 18, dash, dash. So they makes the terms of an AP. So the first term here is 20 and common difference is 19 minus 20 is minus 1 and the sum is 200. First, we will determine the number of terms in the AP using this formula. So what happens, you see, Sn is equal to n by 2 into 2a plus n minus 1 into d is the formula. Sn is 200. N we don't know. You keep at n by 2 into 2a. 2a is 20. So 2 into 20 plus n minus 1 into d is minus 1. Simplified. This 2 comes this side. So it becomes 400 is equal to n into 2 into 20 is 40. And you multiply this minus into this bracket. So it becomes minus n plus 1. Or 400 is equal to n into, so this 40 plus 1 is 41 minus n, or 400 is equal to 41n minus n square, multiplying this into this bracket, or n is equal to, or n square minus 41n, means taking these two terms to LHS side, plus 14 is equal to 0. So this is a quadratic equation having C value 400, and for that 400 we have to determine the factors. The suitable factors for this 400 are 16 into 25 because the difference of these two, the sum of these two gives the middle term 41. So these are the suitable ones. So write the factors in the equation. So n square minus this 41n is written as a minus 16n minus 25un because they are the factors of this 400 plus 400 is equal to 0. So take n common here, it becomes n minus 16 and minus 25 common, it becomes n minus 16 is equal to 0. Or you two terms are there. So n minus 25 into n minus 16 is equal to 0. So this shows that n is equal to 16 or 25, but always we have to take this lower value n as a 16. That means there are 16 rows are there. Then we have to determine how many uh, logs are there in the top row, that is the 16th row. So that is determined here like this. A16 is equal to 20a, it is a value 20a plus n minus 1, 16 minus 1 into d minus 1. So this is equal to 20 plus 15 minus 1, 16 minus 1 is 15 into minus 1. So this is equal to 20 minus 15 is equal to 5. That means there are 5 logs in the top row. So the problem is solved. Next, I will go to the last problem, means the 20th problem of this exercise 1.3. So it is like this. In a potato race, a bucket is placed at the starting point, which is 5 meters from the first potato, and the other potatoes are placed 3 meters apart in a straight line. There are 10 potatoes in the line. A competitor starts from the bucket, picks up the nearest potato, runs back with it, drops it in the bucket, runs back to pick up the next potato, runs to the bucket to drop it in. And she continues the same way until all the potatoes are in the bucket. What is the total distance traveled by the competitor in doing so? So this is the problem. So here that basket is there. These are the positions of the potatoes. She is running. So from bucket, she will start. She will come here and took the first potato and goes back and put into the basket. Then he runs to pick up the potato present here and goes back and put into this bucket. So in this way, she continuously she will be running until all the potatoes are completed. So it is a very interesting problem. and it can be solved very easily with the help of this arithmetic progression. So that is the beauty of this arithmetic progression. Some complicated problems can be solved with this arithmetic progression. So this is the solution. The first potato is at a 5 meter. So the total distance traveled by C to pick up the potato is 2 into 5 meter, because 5 meter to go there and come back. So it becomes 2 into 5 meters gives the 10 meter. Then distance traveled by C to pick up the second potato is 2 into 5 plus 3, because another 3 meter is added to this. So it is 2 into 8 is equal to 16. To pick up the third potato, the distance traveled is 22 meter. To pick up the fourth potato, the distance traveled is 28 meter in this way. And so the terms are generated here. And so the terms of the EP generated in this case are 10, 16, 22, 28, dash, 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 like that. And here A is equal to 40, it is the first term, and D is the common difference. That is 6 minus 10 is equal to 22 minus 16, or it can also be 22 minus 28 minus 22 is a 6. And the total terms here are n is equal to 10. And therefore, simply we have to determine the sum of these numbers generated by my making use of the distance formula to get the total distance traveled. So the sum formula is S10 is equal to 10 by 2, because n by 2 into 2a, 2a is 10, so 2 into 10 plus n minus 1, 10 minus 1 into d is 6. So this is equal to 5 by 2 is 10 by 2 is 5 into the bracket 2 into 10 is 20 plus 9 minus 10 minus 1 is 9 into 6. This is equal to 5 into 20 plus 9 into 6 is 54. This is equal to 5 into 12 plus 54 is a 74. So 74 into 5 is a 370 meter. So S10 is a 370 meter. That means she traveled a total distance of 370 meter to collect all the potatoes and put back into the basket. So in this way, all the 20 problems of the exercise 1.3 of this arithmetic progressions are solved and explained. And only thing is that you have to practice these problems 2-3 times, then only you will become the perfect. Otherwise, there may not be perfectness in the solution. So these are the solutions, and so thanks for listening.